Okay, we meet again. For the first part of my video, okay, I already mentioned, okay, for impact test, normally we refer one very important graph that we call as a DBTT curve graph, right? So what is the DBTT means? Okay, the next slide, I will share with you uh, very important information about the DBTT curve. Okay, not DBBT. Okay, actually it's the DBTT curve. Sorry, it's my mistake. Right. What is the DBTT means? Okay, the awareness of brittle fracture under service condition will be made by the use of ductile to brittle transition temperature curve. Okay, and then this curve is very sensitive fracture phenomena. Okay, before I further proceed with this graph, okay, with this curve, okay, I want to attract your attention, okay, where we can apply this kind of curve in real engineering scenario. Okay, maybe some of you have watched the Titanic movie. Okay, what happened in the Titanic movie? Okay, at the beginning of that film, okay, the engineer uh, the that engineer and architect who design and fabricate the Titanic ship, okay, they claim that this Titanic ship, I think, is the most studied ship in the world during that time. Okay, so they claim that they can go to Antarctic sea is easy as that. Okay, but when they design the ship, okay, they're using a lot of steel material. Okay, when they're fabricating, why the steel material is good? Because number one, it's easy to design, it's easy to shape, okay, by riveting, shaping, and etc. But the architect and engineer, they are they forget about one thing. Okay, they forget about to consider what happened to the metal material when they I mean cruise, okay, on the sea that have the temperature is below than 0 degree. Okay, what happened? Okay, inside the movie, okay, this ship already cruise about 7 to 8 hours, and then they are reach the sea near to the North Pole there. And then of course in the North Pole they have a lot of iceberg. Okay, in that film, this Titanic cruise, okay, cruise, and then suddenly they crash, okay, with the iceberg. And then what happened when this ship crashed with the iceberg? Okay, when this Titanic ship crashed the iceberg, okay, this iceberg, of course, when they crash, they produce a very high impact because the impulse, right? So meaning that when they crash together, they create the brittleness at the surface of the metal, because the metal tend to shows the brittleness properties when the temperature is below than a frozen temperature, is zero, below than zero. Okay, that's the first example. I give you second example. Okay, what happened? Let's say this one, for the sake of example only. Okay, if you watch in the movie something like James Bond or Mr. Bean movie, okay, when they want to orang kata sneak into our people house, okay, of course dekat rumah-rumah dekat Malaysia, okay, kita ada mangga kan, kunci mangga. So macam mana pencuri, okay, dia nak masuk rumah kita. Okay, dia orang beli one bottle of hydrogen gas. Okay, they spray this kind of hydrogen on the kita punya padlock, steel padlock, and then when they spray the hydrogen bottle towards the padlock, and then towards padlock become brittle and easily knock, and then it's broke. Okay, that's why the DBTT curve come in. Okay, from this DBTT curve, we can see, okay, the change of the ductile to brittle material versus temperature. Okay, in simple word, uh, okay, for this DBTT curve, what parameters that we obtain? We have number one, the absorbed energy. Number two is the H crystallinity. Okay, what is the meaning of this? This one you should find out. But at the beginning of my slide, I already mentioned if the metal is ductile, when you perform the impact testing, this metal have high ability to absorb the energy before failure. Why? Because this crystallinity percentage that form inside the metal structure will help to will help the metal to absorb the energy. And then what happen if we adjust the temperature? Okay, either we increase the temperature for room temperature, or we reduce the temperature into under 0 degree temperature. Okay, in this case, what you should understand from this curve, number one, you should understand how to draw this DBTT curve. Where is the location of the ductile region? Where of the region for the brittle fracture? Okay, and as you can see, when you have the when you perform the experiment, you will get the data and then you will plot the data. Okay, and then normally if we have this loop in between, okay, this one we call it as a transition region, meaning that let's say you adjust the temperature from the, let's say, room temperature, you increase the temperature maybe 40 or 50. That's why the ductile fractures become higher. Okay, why? Because they have tendency to absorb high energy before fracture. But when you change this temperature, okay, there is one phenomenon we call as a transition region temperature. In simple word, we want to see where the temperature is transition between brittle to ductile or ductile to brittle. Okay, this one you should understand. Okay, the lower shelf, the upper shelf meaning that the lower shelf meaning that normally at the under below negative below 0 degree. Meanwhile, for upper shelf meaning refer to the peak of the graph that have increased drastically. Okay, I want to bring your attention here. Okay, I already explained what is the lower shelf, what is the upper shelf, what is the transition. Okay, you need to pay attention on this slide. Okay, because this is a very famous question uh, for your exam as well for your test. Okay, the left side, the middle side, the right side is the different fracture surface. I repeat again, different fracture surface when you perform the impact test at different temperature. Okay, because this DBTT curve we can see from the impact test. So let's say if in the lower shaft, okay, lower shaft meaning that in a very cool temperature, okay, you can see the fracture surface almost flat. Why? Because at this region, the metals already shows the brittle properties, meaning that when you have brittle, it's very easy to break into two pieces. Meanwhile, at the transition mode, or the transition region, okay, you can see something like mixture between upper shelf and lower shelf. Okay, this one you can see some of part is at the center part is flat, but at the edge of the surface, something like you can see it something like the angle of the defect, the angle of the surface may be reduced. But meanwhile, when this metal tested at the upper shelf or the more higher temperature, you can see you didn't get any more the flat surface as you can see at the lower shaft. For the upper shaft, you can see the edge of the metal surface fracture, okay, produce certain angle, okay. You can say something like the necking formation that occurs for the tensile test. You can see, as you can see here on my screen, okay, there is edge of the metal surface. Okay, what is the difference between tensile test and impact test? Why I put this slide? Okay, because a student always do a silly mistake, I can say. Okay, when the question asks you about the tensile test, but the student explain about the impact test fracture surface specimens. Meanwhile, in contra, the question asks you about the impact test, and then suddenly the student explain about the tensile test. Okay, this one we call it as a cup and cone shape specimen. So meaning that the student confused. Okay, when I ask the question, describe about the tensile, blah blah blah, the student explain about the impact, and then in reverse, when you explain, when I ask you about the impact, you explain about the tensile test. Okay, so again, I want to repeat you. Okay, I want to repeat to you this example of two choppy specimen after testing ductile material and also the brittle materials. Okay, I think I already explained this in details before. Okay, here same again. Okay, the same picture that I showed to you before. Okay, but this one is the surface morphology of the specimen under SEM observation. Okay, as you can see, for the fracture surface at the lower shelf at the cool region temperature, you can see the cleavage facet has been formed. What is the cleavage? Okay, the cleavage meaning that there's something like the petal flowers shape here, as you can see. Why? These petal flowers is can show the brittle performance. I think this explanation you will learn in the applied metallurgy letter. Okay, so why this cleavage contribute to the brittleness of the material? That's why you need to find the answer. The answer is related to the grain size. Meanwhile, if in the transition mode, mixed mode of the material between cool temperature until a little bit higher the temperature, so you can see the cleavage, the amount of the size of the cleavage facets become reduced, and then you can see something like the ductile tearing morphology appear here. Okay, meaning that in this case they have combination between the brittle and ductile performance. Meanwhile, when you heat up, when you perform the impact test at more higher temperature than 10 degrees Celsius, so you will get the ductile tearing with the microvoids. Okay, microvoid meaning that when you pull them, when you do perform the impact test, there were microvoid coalescence in ductile failure. Okay, again, what is the significance of DBTT curve? Number one, to select a material which has sufficient notch toughness when subject to severe condition. Determine the temperature above which brittle fracture will not occur at elastic stress level. Okay, in simple word, the most important significant finding for the DBTT curve is when you adjust the temperature during impact testing, you might get number one, different absorbent energy. Number two is different percentage of age crystallinity. Number three is that you will gain a different microstructure of the fracture specimen after you perform the impact test. Okay, I think that's all for now for the part 2 of my video. The latter part, I will cover the last part for the impact